Okay, welcome to iChem Lesson 5 on ionic bonding using those Roman numerals we avoided in class today. You will need a periodic table out in front of you and your list of polyatomic ions from your notes from class Friday. These two things should probably be with you all the time for the rest of time in chemistry class for the most part. Okay, so what is the purpose of the Roman numerals? The reason why we even have them in the first place is because the transition metals and those in group 4A have unpredictable cation charges. The Roman numeral communicates to the reader which form of the ion was used to create the compound. For this part, there's not a whole bunch that you need to write. Just sort of sit back and watch, and then on the next slide, you'll be responsible for taking more notes. So for the first example, we're talking about copper 1 oxide. The 1 here tells you that it's copper plus 1, okay? Then the oxide, we already know that's oxygen. This is same old from before. Oxygen is a -2 charge. We're going to swap and drop and end up with Cu2O. So let's look at this real carefully. Copper 1 ends up with a subscript 2 for copper. The Roman numeral does not tell you the subscript, it tells you the charge, and then you follow the rules before. So if I say copper 1 oxide, it's actually copper Cu2O. Okay, next example. Copper 2 oxide, that tells me it's copper 2 plus. Same thing. O2 minus, oxygen's always 2 minus. Swap and drop the charges. I have Cu2O2. If we remember our step 3 in writing the formulas for ionic compounds, we're taking that greatest common factor and simplifying it to CuO. So even though there's a 2 in the Roman numeral, based on swap and dropping the charges, I end up with CuO. So the Roman numeral makes a difference in the chemical formula, but it doesn't necessarily tell you the number that should show up in the formula. Okay. So writing the formulas is relatively simple compared to writing the names. Let's just do a couple of examples, and let's take notes on this one. Remember, the Roman numeral tells you the charge value of the cation. So for the first example, I have nickel 2 nitrate. So I'm going to come over here, I'm going to circle my 2 to tell me that I have nickel plus 2. Okay, the Roman numeral tells me the charge of the cation. Nitrite is one of my polyatomic ions. I have to go over to my table of polyatomic ions. I have both my ions. I swap and drop the charges. I have Ni, NO3, 2. Okay, so the 2 told me the plus 2 here, and then business as usual, following the steps to swap and drop. Next example, lead 2 acetate. So the 2 in the Roman numeral tells me the 2 in the charge. Acetate's one of my polyatomic ions. I just find it from our table. And business as usual, swap and drop the charges. So I'll end up with Pb, my acetate in parentheses there, and a 2 on the outside. Again, the Roman numeral told me the charge. Then I need to follow all my steps like we were doing before. It's not quite that straightforward when we're writing the names. When you're given a formula and asked for the name, you cannot take shortcuts. It's not as simple as backwards crisscrossing and getting the charges out. The Roman numeral is not always obvious. For a second, though, I'm going to pause and throw out my secret question, because all this talk of numbers has made me think about how many kids actually grew up in the house with my mom. My mom is the oldest of 11 kids. They all shared one bathroom, and not very many bedrooms growing up in that crazy house. All right, back to business. So the steps. You identify the charge of the negative ion. They are always predictable. We've been using them over and over and over again. Either they're a polyatomic ion, or you can find them based on what group they're in the periodic table. Then you find the overall negative charge of the compound. So that's the charge of the ion times how many ions there are. The metal ion must cancel that overall negative charge. So we need to know how many metal ions we have. And you calculate the metal charge by dividing the overall negative charge by the subscript of the metal. So let's do an example, put it into context. Okay, so in your boxes, I have it laid out just like this, so we can go step by step by step. So first, the charge of the anion. Well, I need to know what the anion is first. If I come over here, I cover up my metal, I see what I'm left with is in the parentheses, it's one of my polyatomic ions. Sulfate has a -2 charge, so my step 1, the charge of the ion is -2. The overall negative charge would be how many ions I have. That's what the subscript tells me, 2 times the charge of those ions, -2. So my overall negative charge is 4. The subscript of the metal, come up here, look for a number. There is no number, so 1 is implied. And I take my overall negative charge and my subscript of the metal and divide them. 4 divided by 1 is 4. This tells me that the charge on tin is 4. So I have tin 4 sulfate as my name. All right, next example. Over here. Cu3PO42. First, charge on the anion. The anion is phosphate. Phosphate always has a charge of -3. The overall negative charge is how many phosphates? 2 times the negative charge, 3. My overall negative charge is 6. The subscript on my metal, I come up here to copper, I see that there's a 3 there. I take the 6, I divide by 3, I get 2. This tells me that the charge on my copper is 2. So I write copper 2 phosphate. Last one. Over here I have titanium and sulfur, a compound containing titanium and sulfur. I need to look over here at my anion. It's S. This is a monatomic anion, so I have to find sulfur on the periodic table and decide what its charge would be. Sulfur is a group 6 element, so it will always have the charge of -2. I'm taking the charge and I'm multiplying by how many I have, which is 2. 2 times 2 is 4. The subscript of the metal up here is an implied 1 because there's nothing written. 4 divided by 1 is 4. So this is titanium with a 4 charge. Titanium 4 sulfide. We name the second part just like we did in class today. If it's a polyatomic ion, you just use the name of the polyatomic ion, like phosphate. If it's an element, like sulfur, we chop off the end and we replace it with IDE. So make sure you have all of this down. Rewatch if you need to. Remember, always have a periodic table and your polyatomic ions right in front of you. You're going to need them quite a bit in the next few weeks. See you tomorrow.